In the last episode, we talked about this insanely great product called Google Maps. I also told you that it relies on using cell phones as surveillance devices. I have friends who swear by Google Maps, and they are constantly gushing about how much travel time they've saved by following the recommended routes. For my Boston trip, Google Maps tells me that I will save 7.8 minutes. When Google Maps tells me it's going to save me 7.8 minutes, is that true? The surprising answer is nobody knows, not even Google. That's because in order to get an estimate of the time saving, you have to compare what I and other drivers actually did on the road relative to what we could have done in another universe. It's impossible to know the travel time of something that never happened. The software could have said 9.8 minutes or even 15 minutes, but nobody can be sure. When people believe that they have saved a lot of minutes using Google Maps, they are often just buying the marketing pronouncements. Let me shift sideways to a question that we have an answer for. Can Google Maps really find the shortest path for every user? The surprising answer here is no. It's not possible for a navigation software to simultaneously benefit every user in the system. When I presented the mathematics behind the shortest path problem, which you can review by looking at the last episode, I skipped an important point, which is that these algorithms are optimizing in the aggregate. It's trying to minimize the total travel time for all drivers on all journeys. It turns out that what is great on average does not necessarily lead to the best individual outcomes. And that's a paradox that I want to unpack for you today. Let me start with an analogy. So I designed a new course in Python programming. My objective is to maximize the total amount of learning in the entire classroom. However, the class consists of a variety of backgrounds. Some students have never written a computer program before, while other students already know a number of coding languages. So you can see that the most learning for the average does not lead to the most learning for each individual. Back to route planners. There's no guarantee that the software will produce the best route for your particular journey, even if it does a good job in the aggregate. Imagine that there are 100 drivers all trying to get from New Haven to Boston. There may be 10 different routes between New Haven and Boston. Given the current state of the traffic, there is one shortest route. If the software sends all 100 drivers down this shortest route, it will no longer be the shortest route. So if the software tries to minimize the travel time for everyone, then some of the drivers are going to be sent down something that's not the shortest path. The road capacity is fixed. One driver's gain is another driver's loss. This issue is one of the biggest unsolved problems in AI and data science algorithms. Who is going to get that shortest route and who isn't? It's an issue of fairness. We've come to the end of another episode of Fung with Data. We've encountered one of the biggest unsolved problems in AI and data science, which is that optimizing for the social good does not lead to individual best outcomes. So is it okay for a tech company to claim that it is giving you individuals the best outcome when it is only optimizing for the average? How should the algorithm decide who gets the shortest route and who doesn't? Life's not as fair as you think. If you like what you heard today, please like our video, subscribe to our channel, and spread the word. Please also send us any ideas you have about future topics as we demystify the world of data and algorithms. Comment your ideas below. Principal Analytics Prep.
prepping you for the data revolution.